It tests whether a candidate can recognize that pre-sorting simplifies interval matching from quadratic time to a single linear sweep, which is a key concept in timeline construction and event processing. In distributed payment systems, transient failures trigger client retries, transaction logs, and database locks. When multiple components execute concurrent retries, they produce overlapping processing intervals. A frequent data engineering interview question is to merge all overlapping transaction windows to compute the total active processing duration. Let's see why naive comparison logic fails when throughput spikes. Under pressure, candidates often check all interval pairs against each other. They use nested loops to find overlapping pairs, merge them, and append them to a new list. This brute force search compares every transaction log with every other transaction log. While it works on short logs, it is a dangerous quadratic trap. This brute force algorithm requires O of n squared time. If your batch processes 1 million transaction records, the system must execute 1 trillion comparison steps. This causes extreme CPU latency, blocks the downstream pipeline, and can lead to thread exhaustion. We must find an approach that avoids checking non-overlapping pairs. The optimal solution uses a simple sorting step to eliminate the pair checks. First, sort the intervals by their start times. This guarantees that any overlapping intervals must be adjacent. Then, perform a single linear sweep. If the next interval starts before the current one ends, we merge them by updating the end time to the maximum of both. Otherwise, we push the current interval to the output and start a new one. Let's check our edge cases. If one interval completely swallows another, like 1 to 10 and 2 to 5, our max comparison ensures the end remains 10 rather than shrinking to 5. Also, adjacent boundaries, like 1 to 3 and 3 to 5, are merged correctly using the less than or equal to check. Empty logs and single entries are handled immediately by the initial guard clauses. Remember the interval merge blueprint. When managing transactional timelines or resource reservation logs, sort by the start time first. This reduces the search complexity to a linear O of n pass. Always track the active window and use a max check to update the end bound. Master this pattern to write high-performance log parsers and timeline aggregates. Let's analyze the brute force pair comparisons trap approach. Time complexity, O of n squared. Space complexity, O of n. Comparing all pairs leads to quadratic execution, failing on production-scale transaction streams. Let's analyze the sort and linear merge, correct, approach. Time complexity, O of n log n. Space complexity, O of n. Sorting by start time allows a single O of n sweep to perform all merges efficiently. The interviewer will then ask, what if transaction logs arrive out of order in a distributed stream? Apply a sliding event time window using Apache Flink or Spark structured streaming, buffering and sorting intervals per partition before merging. The interviewer will then ask, how do you calculate total active processing duration after merging? Sum the durations of all merged intervals. Sum and start for each interval in the output list.